Section 7.5 is on dividing polynomials. In the first part, we're going to be dividing by a monomial. So we're going to divide by a monomial, a single term in its denominator. You can do that by separating the numerator into separate fractions. So for instance, if we have 5x minus 15 over 25, we can separate this into the two fractions, 5x over 25 minus 15 over 25. And then we can reduce each fraction. So the first fraction, 5x over 25, is going to reduce, divide both of these by 5, to 1x, or x, over 5, minus 15 over 25, divided both by 5, will reduce to 3/5. So that's been divided and simplified. Let's look at part B. We're going to do something similar here. So we're going to separate the top, the 18x to the 5th, over negative 6x to the 3rd, then plus 5x to the 4th over negative 6x to the 3rd, minus 6x to the 3rd over negative 6x to the 3rd. Now reduce each of these fractions. A positive 18 and a negative 6 is going to give us negative 3. X to the 5th divided by x to the 3rd is x squared. Positive and negative is going to be negative. And you can't reduce the fraction 5/6, so we're going to have 5/6. And x to the 4th over x to the 2nd is going to give you x. You either write the x on the top of the 5 or off the side, it's the same result. Finally, negative and a negative is going to be a positive, and when you reduce 6 over 6, you get 1. And x to the 3rd divided by x to the 3rd, the x's cancel out, so you just have that 1 there for your third term. Let's look at part C. In part C, I want to separate the numerator again, so I'm going to have 6w to the 5th p over 6w squared p plus, and we're going to have 12w to the 4th p squared over 6w squared p. Finally, plus 2w to the 3rd p to the 3rd over the 6w squared p. Let's reduce each of these fractions. 6 over 6 is 1. W to the 5th over w squared is w to the 3rd, and p divided by p is also 1, so just w to the 3rd for the first term. Plus 12 divided by 6 is 2. W to the 4th divided by w to the 2nd is w to the 2nd, 4 minus 2. And p squared divided by p, this is a single p. Plus 2 over 6 is going to reduce to the fraction 1/3. W to the 3rd over w squared is w, and p to the 3rd over p is p squared. Let's compare the process here. If you have a monomial times a binomial, you're going to distribute the multiplication. In this example, we would get 6x squared plus 15x. If you have a monomial divided into a binomial, you're going to distribute that division. When you distribute the division, that would give you 6x squared divided by 2x minus 10x divided by 2x, or 3x minus 5. So when I'm dividing by a monomial, it's similar to using the distributive property. If instead I'm dividing by a binomial, I'm going to have to use long division. So let's look at an example of regular numeric long division so we can compare that to what we're going to do with our polynomials. If you want to divide 15 into 3,981, first you say 15 goes into 39 twice. 15 times 2 would be 30. Then you subtract. 39 minus 30 is 9. Bring down the 8. 15 goes into 98 6 times, because 6 times 15 is 90. When you subtract, you get 8. Bring down the 1. Now 15 is going to go into 81 5 times, and 5 times 15 is 75. When you subtract, you get a remainder of 6. Therefore, the answer is 265 plus 6/15. The remainder of 6 is out of 15 since there are 15 parts. Let's look at example 2. In example 2, we're going to be using long division with polynomials, so we're going to model it off the process that we use when we use long division with numbers. Okay, so the divisor, the number on the bottom, The polynomial on the bottom goes on the outside of the long division bar. So I'm going to have x minus 2 on the outside. And we're going to divide that into 5x squared minus 7x minus 6. Just like with the numbers here, we asked ourselves the question, what do we need to multiply 15 by to get something close to 39? It was going to be 2 to get 30. I'm going to ask myself, what do I need to multiply x by to get 5x squared? I need to multiply x by 5x to get 5x squared. Now we're going to take that 5x and we're going to multiply it by both the x and the minus 2. That's going to give us 5x squared minus 2x. Now, just like numeric long division, we're going to subtract. So we're going to subtract 5x squared minus 5x squared is 0, and 7x minus 2x, that negative and this minus right here, are going to turn that into plus, so that's going to be negative 7 plus 2, or negative 5x. Bring down the next term, the negative 6. Okay. What do you need to multiply x by to get negative 5x? Negative 5. Now we're going to take our negative 5, multiply it by both terms. That'll be negative 5x plus 10. Now, again, we're going to subtract. When I subtract, 5 minus negative 5 is going to be 0. And negative 6 minus 10 is going to be negative 16. So the answer is, on the top right here, 5x minus 5 with a remainder of minus 16. So the remainder gets written over the divisor. So my final answer is 5x minus 5 minus 16 over x minus 2. The next one I have 4x minus 1 divided into 12x squared minus 23x plus 2. So that's 4x divided into 12x squared. What times 4x gives me 12x squared? 3x. So 3x times 4x is 12x squared, and 3x times negative 1 is negative 3x. Now we subtract. Make sure you remember to distribute the subtraction sign. That's going to make this a negative 12 and a positive 3. Therefore, I'm going to get 12 minus 12 is 0x squared. Negative 23 plus 3 is negative 20x. Keep going. What do I need to multiply 4x by to get negative 20x? Negative 5. Negative 5 times 4 is going to be negative 20. X, and negative 5 times negative 1 will be plus 5. Subtract. So the subtraction symbol is going to make 2 negatives make that positive, 1 negative make this one negative. So that's going to give us negative 20, and 20 is 0x, and 2 minus 5, a remainder of negative 3. Final answer here, 3x minus 5 minus 3 over 4x minus 1. Let's check out the next page. My divisor is 2x minus 1. I'm dividing that into 6x cubed minus 11x squared plus 5. So what do you need to multiply 2x by to get 6x cubed? It needs to be 3x squared. So 3x squared times 2x is 6x cubed. 3x squared times negative 1 is negative 3x squared. And we subtract. Subtract both of these. So the negative is going to make a negative, and then the next negative is going to make a positive. So 6 minus 6 is 0, and negative 11 plus 3 is negative 8x squared. Bring down the next term. The next term, since it goes x cubed, x squared, would be the number of x's. So there actually aren't any x's here. So let's just write in plus 0x. This 5 is not actually the next term. There's a missing term in here since I don't have an x term. And let's keep going. What do you need to multiply 2x by to get negative 8? That'd be negative 4x. Negative 4x times 2x is negative 8x squared. We're exactly the same thing here. And negative 4 times a negative 1 is going to be a positive 4x. Now we subtract. When we subtract, the negative is going to make it a positive and a negative. Okay? So negative and positive add to 0, and 0 minus 4 is negative 4x. All right. What do you need to multiply 2x by to get negative 4x? Well, that would be negative 2. Negative 2 times negative 2 is negative 4x. And negative 2 times negative 2 is plus 2. Let's bring down our 5 and subtract. When I subtract, I'm going to get a negative and a negative making a positive, and a positive and a negative making a negative. Negative 4 plus 4 is 0, and 5 minus 2 is a remainder of 3. Therefore, my final answer here is going to be 3x squared minus 4x minus 2. That 3 is positive, so plus 3 over 2x minus 1. Let's look at part B. The divisor is x squared, so I have x squared plus 3 divided into 3x cubed minus 4x squared plus 9x minus 16. What do you need to multiply x squared by to get 3x cubed? That would be 3x. 3x times x squared is 3x cubed. And 3x times 3 is 9x. I'm going to write that one underneath the 9x so that I have my like terms lined up. Let's subtract. 3x cubed minus 3x cubed is 0. Bring down the next term. Negative 4x squared. Now 9x minus 9x is 0. Bring down the next term. What do you need to multiply x squared by to get negative 4x squared? That would be negative 4. Negative 4 times x squared is negative 4x squared. And negative 4 times a positive 3 is negative 12. Subtract. Negative and negative will make positives. And negative and 4 and positive 4 add to 0. Negative 16 and positive 12 add to negative 4. So my final answer here is going to be 3x minus 4 minus the remainder 4 over x squared plus 3. Well, the next page is optional. Synthetic division is an alternate way to do long division. In synthetic division, you're going to start with the solution to the bottom. So the bottom, if the bottom was an equation, x minus 1 equals 0, if you add 1 to both sides, the answer would be x equals 1. So I'm going to start with a 1, the solution to setting the bottom equal to 0, in that little box right here. And I'm going to use only the coefficients as I write this out here. So the coefficients are 3, negative 7, and 1. The first coefficient always gets dropped down, 3. Okay, now I multiply 1 times 3. 1 times 3 is 3. And add negative 7 plus 3 is negative 4. Multiply again. 1 times negative 4 is negative 4. And add 1 plus negative 4 is negative 3. Okay. The final item here is always the remainder. And since this was x squared, x, and constant, when I divide out an x, I'm left with one fewer power. So my powers have to be x, then constant. It was x squared, so now this one's x. So the power gets reduced by 1 when I divide. So this would go back to the coefficient 3 of x minus 4 minus, the remainder was 3 over x minus 1. You can check your answer by using long division and you get the exact same thing. In part B, let's try this one again. If I take the denominator, x plus 1, and set it equal to 0, I'll find that x would be equal to negative 1. So we're going to start with negative 1 in a little box right there, and we're going to list just the coefficients of the polynomial. So it'll be 2, negative 5, and negative 10. Drop down the first number, 2. Negative 1 times 2 is negative 2. Now add. It was negative 7. Let's do a multiplication again. Negative 1 times negative 7 is positive 7. And add negative 10 plus 7 is negative 3. And the last one's the remainder. So this translates back to, since the power of originally was x squared, 1 less, we'll make this 2x minus 7 minus the remainder 3 of the divisor of x plus 1. Let's do a couple more for practice. C, the denominator is x minus 5. If you set that equal to 0, that would give you x equals 5. So 5 is the number that we start with in our box. And now we do the coefficients. Now these coefficients absolutely must be in order. So x cubed is a coefficient of 2. X squared is a coefficient of 11. X is a coefficient of 8. And negative 17 is the constant. They're not written in the correct order, but I must put them in descending order. Power 3, power 2, power 1, power 0. Okay. Now our line, and we drop the first one down. That's 2. 2 times 5 is 10. Negative 11 plus 10 is negative 1. Times 5 is negative 5. 8 minus 5 is 3. 5 times 3 is 15. Negative 7 plus 15 is negative 2. And the last one's the remainder. This was power 3, so 1 less is power 2. This is going to be 2x squared minus x plus 3, with the remainder of 2 minus 2 over x minus 5. And the last one. Part D, the denominator is x plus 3, so it's going to correspond with x equals negative 3. So I have negative 3, and the coefficients, the coefficient of x cubed is 2, the coefficient of x squared is 7, the coefficient of x is 0, the coefficient of the constant is 5. These must absolutely be in order, and if there are any holes, any missing pieces, 3, 2, power 1 is missing, I have to fill it in with a 0. 2. Negative 3 times 2 is negative 6. Add that to negative 7, you get negative 13. Times negative 3 is 39. Add that to 0, you get 39. And 39 times negative 3 is 117. Negative. Add that to 5, and you get negative 112. So this was power 3, so my answer is going to have power 2. So x squared minus 13x plus 39 minus 112 over x plus 3. We can check any one of these that we've done synthetic division by performing long division. We'll get the exact same answer.